is the last video in this unit, writing linear equations. So we are going to take what we learned with input-output tables and independent-dependent variables and graphing linear equations, and we're going to really wrap it all together. So your goal is I can write an equation from for a linear function from a table, graph, or a word problem. But before we get into that, let's do a couple review problems first. So the table shows the relationship between the number of quarts and the number of cups. So write an equation. So what is the rule? So the first thing I'm going to do here is the Q's and the C's, I'm going to change them into X's and Y's. Because I also know that my equations should always start with Y equals. And so I'm trying to figure out what is happening here. So how am I getting my y's here? How am I getting my cups? And so how am I getting from 1 to 4? How am I getting from 2 to 8, from 3 to 12, from 4 to 16, and from 5 to 20? Well, it looks like I am multiplying by 4. So y equals 4 times x. But just to be sure, I'm going to check. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and 4 times 5 is 20. So that checks out. All right, review number 2. So the Davis family drove to their cousin's house for Thanksgiving weekend. Mr. Davis was able to drive 60 miles per hour. So first off, what's the independent and dependent variable and the equation? So here we have miles and hours. So what's the independent and the dependent variable? So are the hours dependent on the miles, or are the miles dependent on the hours? So the hours are dependent on the miles. Okay? So I'm sorry. Wait, now I'm getting myself all confused. So Mr. Davis was able to drive 60 miles per hour. So the miles are, wait, I have to write my equation down here. Now I got myself all confused. Okay, so the miles are dependent on the hours. Yes, okay, I said that correctly. So miles are dependent on the hours. So the more hours that you drive, the more miles that you drive. The less hours that you drive, the less miles that you drive. Okay, so what is your equation then? Whew, I got myself all mixed up. So if you have M and you have H and you have 60, well, I just wrote the equation down, so you kind of were able to cheat there. You do know that your independent variable is always connected in some way to an operation, okay? And then you know that your dependent variable is usually on the other side of your equal sign. So this is going to read M equals in some fashion, and in this case it's going to be M equals 60H. And an easy way to think about this is if you drove for 1 hour, so put a 1 there, how many miles are you going to drive? 1 times 60 is 60. If you drove for 2 hours, 2 times 60 is 120 miles, so on and so forth. Okay, so let's go ahead and fill out this table. So our equation is M equals 60H, now that I've thoroughly confused you. So let's go ahead and determine how many hours we want to drive. So we want to drive 1, 2, 3, 4, and 5 hours, just enough to sort of get our line going here on our coordinate plane. So we need to plug it into 60. So 1 times 60 is 60. 2 times 60 is 120. 3 times 60 is 180. 4 times 60 is 240. And 5 times 60 is going to be 300. And now we need to go ahead and graph. So this is our X, this is our Y. So 1 and 60, 2 and 120, 3 and 180, 4 and 240, and 5 and 300. And then we want to make sure that we connect our line just like that. All right. Okay, so let's get into writing linear equations now that we've done those two reviews. So step one with writing linear equations is I'm going to give you only a graph this time, okay? And what you're going to do is you're going to take this graph and you are going to create an XY chart by taking the points off of the graph and writing the ordered pairs into the graph. And so I'm going to show you with this example. So here on the graph, I have the point 1, 3. And I have the point 2, 6, and I have the point 3, 9. Okay, so that's step one. Step two is you're going to determine the equation or the rule. Okay, and remember that our equation is always going to start with y equals. So how do we get to 3 and to 6 and to 9? Okay, from 1, 2, and 3. And so you'll have to think about that for just a minute. But what it looks like is it looks like I can multiply by 3. So let's do y equals 3x. And then step 3 is going to be to check the equation with each ordered pair. And so let's do that now. And so the way that we do that is we're going to take y equals 3x and we're going to insert each ordered pair into it. So we're going to put the 1 in for x and the 3 in for y. And we should get equal answers. So that checks out. Now we're going to put the 2 in for x and the 6 in for y. Okay, now we're going to put the 3 in for x and the 9 in for y. And so as long as they all check out, your answer is correct. All right, let's go ahead and do an example. So the graph shows the number of dollars Sarah earns per hour earns per hour every hour she works. That should say per. Ooh, I'm full of typos on this one. All right. Let's see. The graph shows the number of dollars Sarah earns. Let's take out that per every hour she works. Let's do that. Okay, so first let's pull the points off and put them into the XY chart. Now in this situation, you're going to see that we have more points on the actual graph than we do on our XY chart. And that's okay. You have a couple options here. You can make your XY chart longer, but you really just need enough points in order to create your equation. A good rule of thumb is having 3 points, okay? So I'm going to take 120, and then I have 240, and 360. Okay, and our equation always starts with y equals. And so how do we get 1 to 20, 2 to 40, and 3 to 60? So it looks like we multiply by 20. But let's go ahead and check our answer. So y equals 20x. So I'm going to put 20, put 1 in for x. So 20 equals 20. That works out. Y equals 20x. So I'm going to put 40 in for y, 2 in for x. 40 equals 40. That checks out. Y equals 20x. I'm going to put 60 in for y, 3 in for x. 60 equals 60. That checks out. So our equation is correct. All right, example 2. The graph shows the relationship between Gavin's age and Cecilia's age. So let's go ahead and pull off our coordinates. So we have 0, 3. We have 1, 4. And 2, what is that? 2, 5. All right. So our equation always starts with y equals. And so what's happening between x and y? And it looks like they are increasing by 3. So I'm going to do x plus 3, but now I'm going to go ahead and check my answer for each one. All right, so this was 3 equals 0 plus 3, so 3 equals 3, so the first one checks out. Okay, so this was 4, 1 plus 3, so 4 equals 4, that one checks out. And then this is 5, 5 equals 5, and that one checks out. So our equation is correct. Y equals x plus 3. All right, I have 2 challenge problems. I am not going to do these because they are challenge problems. I will give you 5 points of extra credit if you can figure out the equation for both of these. You have until the end of the week to turn them into me, and you need to prove to me by checking each ordered pair that they work for your equation. So you can always re-reference this YouTube video if you need to, but I'm not going to solve them on the video. All right, that is the end of this lesson. It was nice and short and pretty sweet, and we will practice some more in class.